Hello all. So we are going to start today unit 2nd, that is things in IoT. So syllabus. So this is your unit 2 syllabus. The unit name is things in IoT. So in this lecture we are going to see what is sensors, light sensor, voltage sensor, temperature, humidity, motion, wireless, level sensors, USB sensors, embedded sensors, distance measurement with ultrasonic sensors. Then what is actuators we are going to see here. Then electronic communication protocols like I2C, SPI, UART, USRT and CAN. So these protocols we are going to see in this unit. Let's start the unit. So sensor. What is sensor? A device which detects or measures a physical property and records, indicates, otherwise it respond to it. Means it is a simple device which is going to measure and just responding the activity, means to communicate with the environment. Okay, so there are numerous definitions as to what sensors is, but I would like to define a sensor as an input device which provides an output signal with respect to a specific physical quantity, okay, which is input. The term input device in this above definition of a sensor means that is a part of a bigger system which provides input to a main control system like a processor or microcontroller. Okay. So what is need for the sensor? For any system to interact with the environment, sensors and actuators are needed. Okay. Atomization can't be imagined without sensors. They are embedded in our bodies. Automobiles, cellular telephones, aeroplanes, radios, industrial plants and many other applications require sensors. So what is sensor? So on screen what you are going to see into the image, that is humidity, smoke, color, touch, ultrasonic, infrared, accelerometer. So these all are the kinds of sensors. So what is sensors again? Sensors are the devices or machine which are going to be used to detect a presence of any physical object in the vicinity or to send the information about the same to a receiving end. Okay, or you can say the device which is mostly used. So these are the variety of combinations of definition. Okay, just I am showing to you on the screen. The device is mostly used with other electronic devices and physical quantity like pressure, force, strain, light, etc. can be identified and converted into a desired electrical signal. Okay, this will be the third definition for all of you. Basically, these are classified as analog or digital sensors. We are going to be classifying this. I will show the slide next. Other include temperature, ultrasonic, pressure, proximity sensors. It uses less energy and high performance. Okay, data collected from the environment using the sensors and used for the Internet of Things. So I am also going to show you the screen that is showing the types of sensor today only, but for the sake of time we live in the world of sensors. So you can find different types of sensors in our home, offices, car, etc., working to make us life easier. Okay, by turning on the lights, by detecting our presence, adjusting the room temperature, detect the smoke or fire, make us delicious coffee, open garage doors or close the garage door as soon as our car is near the door and your door get open. Okay, so many other tasks. Okay, so this will be the very necessary need of the sensors. You can see on screen in the diagram, you can see the images of the sensors. Okay, so how sensor is going to be look. So at the right downmost corner you can see the soil sensor, soil moisture sensor that I shown in previous videos, color sensor, gas sensor, LDR light sensors, LM35 that is temperature sensor, rain sensor, PIR sensor, water flow sensor, humidity sensor, heartbeat sensor. So you can see into the screen that different types of sensors are going to be look like this. Okay, So characteristic of sensors. Sensors are characterized depending on the value of some parameters. Some important characteristic of the sensors are like static characteristic and dynamic characteristic. Characteristic has been divided into these two main types, static, dynamic. Static means the property of the system after all transient effect have been settled to their final or steady state, means static characteristic. The properties of the system based on the transient response to an input, which are going to be respond to the input, is called as dynamic sensors. Okay, this is the list of the static characteristic of the sensor. It includes range, span, accuracy, precision, sensitivity, linearity, resolution, reproducibility, repeatability, response time. So these are the static characteristic. Dynamic characteristic will be the sensor responds to a variable input to give rise to the dynamic characteristic. The reason for dynamic characteristic is the presence of energy storing elements. Dynamic characteristics are determined by analyzing the response of the sensor to a family of variable input waveforms like impulse, step, ramp, sinusoidal, etc. So sensor or transducer means what actually? Okay. So in a sensor, transducer may be working at a input side also and the output side also. Below in the diagram you can see transducer is going to be work at two sides of the processor, input side and output side, input transducer and output transducer. Okay, when signal is given to the processor, actuators are at the output side. Okay, transducer is a device that convert a signal from one physical to the another physical form. Okay, physical to physical form can be a mathematical, thermal, magnetic, electric, optical or chemical, etc. Sensors and actuators are the type of transducers. Sensor is an input transducer and actuator is as a output transducer. Okay, sensor input side, actuator output side. Okay, so input transducers are working on sensor side and output transducers are working on a output side. So there is a slight difference in between the sensors and actuator is that sensor is a device that changes physical parameter to an electric, whereas actuator is the device that converts electrical signal to a physical form. Okay, finally physical to physical we are getting through the transducers. Okay, classifications of sensor. So based on the power source, active sensors, passive sensors are there. Okay, active sensor require thermal external excitation or a power signal. Example is thermocouple. Passive sensors do not require any external power signal and directly generates the output. Example is thermomisters. Based on means of detection used in sensor are the sum of the detection electric, biological, chemical and radioactive. Classification of sensor based on the conversion phenomenon are some common phenomena are photoelectric, thermoelectric and thermomagnetic, etc. Characteristic based on the output are analog sensors and digital sensors. Analog sensor that produces continuous output signal with respect to a quantity being measured. Digital signals are the digital sensors are the sensor. These sensor work with the discrete or digital data. Example, encoder or IR sensors. Okay, so these are the different types of measurements. Measurements means on the base of what the sensors are going to be sensed. Okay, so thermal, radiation, mechanical, magnetic, chemical and biological form of signals are there. For example, if I have a thermal sensor, what I am going to be sense with the help of that sensor? I am going to sense the temperature, heat flow, entropy, heat capacity, etc. Suppose I have a radiation sensor, then I am going to sense the gamma rays, X-rays, ultraviolet rays, then visible and infrared light, microwaves, radio waves, etc. If I have a mechanical sensor, then displacement, velocity, acceleration, force, etc. I am going to be sense. If I have a magnetic sensor in my hand, then I am going to be sense magnetic field, flux, magnetic moment, magnetization, magnetic permeability, etc. If I have a chemical sensor, I am going to be sense the humidity, pH level, ion, gas concentration, toxic, etc. If I have a biological sensor with me, then I am going to sense sugar, protein, hormone, antigens, etc. Okay. So these are the real time application of sensor you are going to be see on the screen. A sensor will going to be sense a position, height, speed, temperature, location. Okay, then we are going to be process it. Then after processing, actuators like engine, flap, motor, wings, we are going to be as an output transducers. So real time application of sensors and automatic flight control system consists of several sensors for various tasks like speed control, height monitoring, position tracking, status of doors, whatever. A computer takes data from all these sensors, processes them, comparing them with the pre-designed values. So to computer, computer provides and control the signals to different parts like engine, flap, radars, motor, etc. that help in smooth flying of the flight. The combination of the sensors, computer and mechanism makes it possible to run a plane in autopilot mode. Okay, so this is what all about the real time application of sensors. All the parameters of the sensors, the computers or these all are equally important in building a successful automated system. Okay, this is an extremely simplified version of the flight control system, which is real time application of IoT or sensor. In fact, there is hundreds of individual control system which perform unit task for a safe or smooth journey. Okay, so this is the slide showing to you these are the types of the sensors. Okay, there are many kinds of the sensors, some of them I have listed here. For temperature, thermistor, thermocouples are the sensor. For measuring the pressure sensors are there, optical sensors are there, acoustic sensors are there. Acoustic sensors are fitted in microphones. For example, in where a sensor is a microphone and the loudspeaker is the, what we can say, loudspeaker is the transducer. ओके, सो ट्रांसड्यूसर हम स्पीकर को बोल सकते हैं. सो दीज आर द ऑल आर द लेफ्ट साइड लिस्ट ऑफ द टाइप, दैट इज द टाइप्स ऑफ द सेंसर. थैंक यू फॉर टुडेज लेक्चर.